In this video, we're going to talk about ArrayMesh. ArrayMesh is a tool inside of ZBrush that allows us to create instance geometry to make very complex shapes out of a single simple unit. We'll start by looking at this piece here that we created using scalable vector graphics. If you want to see how we created this object, watch the video on 3D text shapes and SVG, and you can see that we actually used a Z plugin right here, Text 3D and Vector Shapes, to create this bit of geometry. So this is just a single Z tool. You see it's actually triangulated and it's quite low resolution. What we can do is go to the ArrayMesh menu underneath Z tool and turn on ArrayMesh. Now, with ArrayMesh turned on, we have the option to change our repeats and change a variety of other variables here. We're going to do something quite simple. We're just going to turn our repeats up to about 5. Now, it doesn't appear that anything has happened. That's because those 5 repeats are sitting right on top of one another. However, if we look at our head here, you can see that the y-axis is pointing straight up. So if I go to the rotate option here, go to Y amount and set this to 360, that's 360, you see it is now rotated around 360 degrees. If we go to frame mode, you see that only one of those shows up as polyframe. The rest are instances. If I were to take the move brush and make changes to my first instance, it will update on all of those other copies. So these don't exist necessarily as actual geometry yet. They can be converted to geometry, but right now they are just instance geometry. Now we can make further changes to this. I could go to offset and I could change the offset along the x-axis if I wanted these to rotate like this. You see that they are rotating out around along the x-axis and rotating around they're transposing along their x-axis and rotating around their y-axis. If we undo that, if we go to pivot, we can change the rotation pivot, so I can move that along the x-axis as well, and then we can start to rotate these around a central radial point. If we change our repeats, we can increase those. You see very quickly we can start to create pretty complicated mechanical forms using this tool. If I change my pivot again, maybe we bring this in a little bit closer, we can create something like this. Let's bring that back out just a little bit so they're just touching and you get a shape like that. Now again, like I said, this is not geometry yet. These are instances, these are copies. If I wanted to turn this into an actual mesh, I would turn on Make Mesh right here. And now if I go into frame mode, those are all polyframe. So that tells us these are all actual geometry now. If I were to start moving things around, you see that it actually sculpts on all of those shapes, not just the initial instance. So that is ArrayMesh in a nutshell. That's a very, very basic explanation of what it can do. Let's go back now and take a look at it from the beginning. I'm just going to undo back to the point that we were actually still in ArrayMesh. I'll turn my repeats down. And if I wanted to reset everything, what I would do is I would just click the reset button here, and that resets all of my settings. We still have the sculptural changes to the mesh here. If I continue undoing, I could undo back to the very, very beginning of the actual mesh, like so. So make sure that we reset our settings, and we have a basic ArrayMesh now. Starting from the top, if we go to the Lightbox Array presets, you see that we have a variety of presets here, and these can be quite handy for learning the tool. If I were to open up any of these presets, it would then apply that to my current Z tool. So here I have applied that spiral array mesh to this particular Z tool, and then I could come down here and change my various settings. Maybe I want to adjust the pivot. I can change the pivot like so, expand that out, and we get something that's a wider spiral. Perhaps I want to change the Y amount of that. If I bring that up, it starts to spiral up in space. Let's bring that back down so we can see that a little bit clearer. If I change my repeats, I turn them up, I get more instances, turn them down, I get fewer. Now I can align to path. If I turn this on, it will align those instances along a path. So you see that gives us an even different look. Sometimes that's quite desirable if you have like a repeating mechanical part that you want to align along that path. Right now it's aligning along the Z path. I can change that to X, or I could change that to Y. There we go. There's X, Y, and Z. And those are just little buttons right there inside of that button. And again, if we change our repeats, we can increase those or decrease them as required. Now I'm going to reset once again. So we'll click the reset button here. Now we have a button called transpose. So I'll turn on ArrayMesh again and then turn on transpose right here and press W for transpose. Now it's going to default to the transpose gizmo. If I turn off gizmo mode here, now we have the transpose line, and you can see the transpose line is a little bit different this time. It has a stage number and a repeat number. So any change that I make with this transpose line is going to be represented with these sliders here. So this is just an easier way of manipulating our sliders. So let's say, for example, I want to transpose move this up in the Y direction. So if we go to offset, you see it has now changed my Y direction. Let's update that again. Let's move that up. You see that that value changes based on my transpose units. Let's say I want to go to rotate. We'll go to rotate and let's change to the X axis here, and then we can just click and drag and then rotate that like so. If we go to rotate, you see that updates. Now if I change my repeats, they will repeat along that path. So transpose is a really nice way of actually manipulating without having to come in here and get very specific with the sliders. We can create the shape that we want to see right off the bat. If I go back to rotate, I can rotate using transpose and see the shape that I'm going to get. If I want to rotate it around this axis, I just click there and rotate. And my geometry will update in real time. You'll also see there's a stage button here. Now, stage allows us to chain together different transpose or different ArrayMesh stages. So this is just a single stage right now. I can append a new stage, and we'll take a look at that in just a little bit. But I just want to point out that that's what stage actually means. We've already seen reset and delete. We can delete a stage, or we can reset it. We can also copy a stage and then paste it into a new stage. The smooth slider will affect the transition between two stages. We've already seen aligned path. Now we have the ability to change patterns here. So I can change pattern start. I can change the point that my pattern starts. And then I can change my pattern on here. So stage pattern on, stage pattern off. So there you see we can change our staging. So that is the number of instances that we get for each particular stage pattern. So within this stage, it's on at 2, off at 9. I can turn that up or down. I can also change the length of the pattern here, like so. Now we can mirror our axis like this. So this is X mirror, there is Y mirror, and Z mirror. And then we've got our alignments. There's the X-axis alignment, Y-axis, and Z-axis. So let's open up a different Z tool now. And by the way, all of these Z tools are available for you to download with the files for this chapter, so you can experiment and follow along as well. Let's take a look at making a spiral staircase using ArrayMesh. So here I have a single section of spiral staircase. You see it's just a simple cylinder with a stair extruded out from it. If we go into frame mode, it's relatively low resolution. Now, if I wanted to turn this into a spiral staircase, I would go to Tool, turn on ArrayMesh, reset any previous settings that you have turned on, and make sure that transpose is turned on. I'll take my transpose line, and let's snap it to the Y-axis, and go to W for move, and I'm just going to move that instance up. And then we can turn up our repeats. Now I can actually click and drag the repeats here to change those repeats. And you can see that it repeats along the Y-axis. Now we can go to rotate, and we want to rotate 360 degrees around the Y-axis. And you see that we actually are not getting the orientation that we actually want. That spiral staircase doesn't have that central pillar anymore. So we want to change our alignment. So what we'll do is we'll go to our pivot control here, go to the bottom, and this yellow circle here is our pivot. And if we bring our pivot right there to the central point of that cylinder, now you can see we actually get our instance rotating around that central point. And we can increase our repeats to give ourselves a nice sort of spiral staircase here. Now, along the instances here, so if we go to offset, for example, and we have the offsets going up the y direction, we have a curve associated with each one of these values. And if I were to change this curve, we could change the acceleration of that change. So I could turn this down, so it's shallower at the bottom and then deeper at the top, and then change our repeats as required to close that distance. We could also go to scale, and if our scale is set to 1 for x, y, and z right now, if I changed my scale here, let's say I brought the scale down, we can change that scale effect here. So I will copy that path, or copy that curve, I should say, and then we will set the next slider here to 0.2, so we'll get it the same scale in each direction. Open up that, and then paste that same curve there. Close that, go to Z, set it to 0.2, and then open up the profile and then paste the curve once again. And that's going to make the X, Y, and Z values the same. So you can see how this can very easily be used to create things like buildings, or, we can even use it to create somewhat organic shapes, which we'll see shortly. But there's things like this that just previously were not possible to create in ZBrush, but ArrayMesh allows us to do this. So let's take a look at another example now. I'm going to close out of the Z tool and open up another one of the demo files that are available to you on disk. So here I've opened up another demo file, and we've got this quite wicked looking alien tentacle here, which is actually just created from a single instance of a human vertebrae. If I change my repeats, you see that we can adjust the length of those repeats along that curve. If we zoom in, you can see quite clearly what we have here. This is just a model of a vertebra that's being duplicated along that instanced curve. Now, if I turn off ArrayMesh, that brings me back to my original vertebrae here. There's the original model. Turn it back on. I can also change my align to path. So here I've got it aligned to a Z path. You can see the difference that that gives us. I can change it from Z to X. Actually, that was Y to X. There we go. We can change our path alignment. We can change the align to axis. So let's turn this off. So we just have align to path, and then align to axis is set to white, or set to Y. Align to axis, Y. There we go. Align to path, Y. So we can change our alignment as it flows along that curve, and then adjust our instances, our repeats, as required. Now, the way we've done this is you see that we've got our scale set to 0.5 all the way down. We have our offset adjusted in Y and X and Z, and the pivot has been adjusted. If we go back to transpose mode, you can see our pivot is here. So if we want to sort of change that tentacle sort of sweep, we would just adjust that pivot like so. So if we zoom out here a bit so you can see more clearly, I just grab the yellow dot, and that is the pivot for those rotations. Now you also see that we have stages here. This brings us to stages. If I go into frame mode, you can see that there's actually 2 stages. Go to the second stage. Now you can see that we're on stage 2. Stage 2 occurs up here. If I change my repeats along stage 2, you see that that's the upper end of that tentacle there. So if I grab this pivot here and change that, it's only changing sort of the sweep along this section of the instance. And this is independent of the number of repeats. I can increase or decrease the repeats here, and it will change just that segment. So let's look at how we actually do this. Let's go ahead and reset our settings. And I'm going to delete this stage and then reset my settings again. And that brings us back to our original vertebrae model. Let's go ahead and F for focus to focus back down on that. And here we go. So if I wanted to create a new instance array of this, I would turn on transpose. Let's go up the W, or the Y-axis, press W for move, move this up. Let's go ahead and just push this up pretty far. Increase my repeats. Now this is stage 1, and there are my repeats going along that instance chain. I can go to scale, or press E for scale, and then I can scale these down using my transpose line. As I scale these down, it will scale them uniform across both X, Y, and Z. If I want to rotate them, I can go to rotate. Let's do rotate around the Z axis. Go to R for rotate, and then we will just go ahead and rotate this like so. And then we'll grab the pivot. So turn on pivot mode, grab the pivot, and then we can change that rotation central axis like this. Now let's say we want to add a new stage onto this. What I will do is I will click Append New, and that appends a new stage. Now I want this new stage to occur at the end of my previous one. So what I want to do is I want to turn on chain, and you see that brings the pivot there to the end. Now I've got a brand new transpose. So let's go ahead and continue with a transpose move up here. And let's go ahead and turn up our repeats. So there's a brand new set of repeats. Let's do a rotation, R for rotate. We'll go ahead and rotate that. And then with the pivot, we'll go ahead and move that. And you see this pivot is just going to affect that section of the staging there. So if we bring that around here, maybe bring it over this way. Let's go to offset. We can offset it over here. Now you'll see it's got this sort of awkward join there between the two stages, which is not really what we want. We want this to be far smoother. What we can do is turn up the smooth slider. If we turn up the smooth slider, it will smooth that transition between those stages. Now if I increase my repeats, you see the effect that we get. Now, once again, if I want to turn this into actual geometry, what I would simply do is go back down to stage 1, make mesh, and that will convert the stage to a mesh. Go to frame mode, and there we go. You see that that is actual geometry. Now we've gone to 3.4 million polygons. Before it was only 15,000. So bear that in mind. If you're not leaving ZBrush, you can actually maintain things as array meshes and keep your poly counts quite low. This will render like geometry. It will take materials like geometry. It will repeat or take on the poly paint the materials of whatever is assigned to the original instance. So there's situations where it's desirable to keep this as instance geometry. Other situations you would definitely want to turn this into an actual mesh. So let's take a look now at another bit of behavior that's quite neat. That is the extrude behavior that will allow us to extrude faces along these instance curves. I'll open up another demonstration tool and show you what I mean by that. Now here I've loaded up the bone tentacle spire. Now this is just a single subtool. Let's turn off ArrayMesh. You can see it's just a very, very simple bit of polygon modeling. What's important to note is the poly grouping is consistent on either side. So if I turn on ArrayMesh, you see that we are transposing this up in the y-axis and rotating it. Now, if I keep extrude turned on, watch what happens when I click make mesh. We'll turn it off. Make mesh, we get what we expect. Each individual instance now becomes a bit of geometry. If I undo that and then turn on extrude, because those polygroups are consistent amongst one another, if I click Make Mesh, it will extrude those polygroups to connect. So we get this nice extrusion along the blue, and we get these negative spaces there. So now if I were to divide this, we can get this very interesting looking sort of biomechanical tentacle shape here. Do a little bit of moving around of that. You can see the very, very interesting shape that we can accomplish using ArrayMesh. And of course, I could array this once again if I wanted to. I could turn on ArrayMesh for this, and then I could go to Rotate, go to R for Rotate, and then let's take our transpose line here and then just rotate this. There we go. And then we'll turn up our repeats along there. And we can then, let's say, rotate it down in this axis here. You can see we can very quickly start to get quite a Giger-esque kind of look. This is a very interesting biomechanical kind of monstrosity that we're generating here. And if I wanted to, I could come into my rotation values here, and then I could just manually adjust these rotations. Maybe I want to just bring this back around like this. Maybe I want to adjust the Y rotation to something like that. And here we go. You see we're starting to get something quite disconcerting. I have 4 subdivision levels that I just added to this, so what I need to do is delete those subdivision levels and then make mesh, and that will generate actual geometry based on that. But see what's happening is it's trying to connect all of those polygroups again. So I need to undo, make sure extrude is turned off, then I will successfully be able to make this into a mesh. Now, these don't really exist as a single object. They're sort of all jumbled up together there in the center. This is a nice opportunity to use one of the modifiers. If I go to the gizmo, turn on the gizmo button here, go to my gizmo modifiers, and we have the ability to remesh by union or remesh by Z-remesher or by Dynamesh. If I take remesh by union, it will take the points where all of those sort of spines are joined together, and it will remesh them so they become a single object. So now if we zoom in here and then turn on frame mode, and we have to really zoom in for you to see it, these have now been stitched together as actual geometry. If I were to hide pieces and parts like that, you see there's nothing inside. It's all joined together as a single volume. That will facilitate allowing you to Z-remesh them successfully as a single object, and it's also just helps make a cleaner model for something like 3D printing, for example, or just working in general. There's many reasons why you would want something to be a single object instead of a whole bunch of objects jumbled up together. And of course, you could accomplish something similar by dynameshing them together or remeshing them together with Z-remesher once they are joined as they are now. If I Z-remeshed these when they were still separate pieces, each individual piece would get its own Z-remeshing. They would not join together. So that is using extrude to actually join your instances, to extrude your instances out along that curve. The last thing I'd like to show you is how you can take an array mesh and turn it into a nanomesh. Now, a nanomesh is an insert mesh brush that has been distributed across a selection of polygons. The difference is nanomesh allows us individual controls over the instanced geometry. So each copy, I can change parameters on it, whereas ArrayMesh, I just change the parameters of the array as they instance along a path. So I'll open up a different Z tool, open up a skull, and we'll create sort of a wall of skulls using the ArrayMesh tools. Then we'll convert that to nanomesh and see how that gives us some more control. So here I have a Z tool, which is just a decimated skull. And I'm going to go to ArrayMesh, and I will open up the ArrayMesh presets, and we're just going to grab one like this. This is an offset sort of brick wall. So if I double click that to open that up, go into F for focus, zoom this out, we'll be able to see this is a series of skulls that are sort of offset, kind of like a brick wall here. It goes up quite high. You'll also notice this has multiple stages. So if I go up to stage 3, you see stage 3 has 8 repeats. So if I dial this down, you can see I can reduce the height of that. If I go to offset and change my offset here, I can bring that back down. Go to stage 2. You see stage 2 let's change back to stage 1. There we go, stage 2. I can take stage 2 and adjust that offset. So watch what happens as I bring that up. I can change the distance between those. So stage 1, if we go back here, is my first row of skulls. That is translating across the X amount here. Stage 2 now moves up in Y and offsets ever so slightly. Stage 3 repeats, alternating going up, so we're able to create this sort of wall of skulls like this, but we don't have any control over those individual skulls. That's a problem. So these are quite obviously just repeating the exact same skull at the exact same orientation. So that's where NanoMesh would come in handy. Now, NanoMesh has its whole chapter. If you have not seen that chapter and you want to learn more about NanoMesh, definitely watch it. It's a wonderful sort of complement to ArrayMesh, and you'll see now kind of the difference between them and what's so valuable about them. So if I click Convert to NanoMesh, it will take this and then create a polygon plane for each one of those skulls. Now, if I go into frame mode, we can't see those skulls in frame mode because they are, once again, instances. They are nanomeshes. Nanomeshes are instance geometry that are distributed across polygon faces. That's the difference between NanoMesh and ArrayMesh. Also, NanoMesh now, if I close the ArrayMesh button and open up NanoMesh, NanoMesh gives me individual control over each one of these instances. So for example, if I wanted to change the overall size, I can do this. I can change the size of each one of those skulls. Now, if I wanted to change their rotation, let's say around the Z-axis, I could do this, but they're all rotating the same way. What's nice about NanoMesh is I can go into NanoMesh and I can do my Z rotation and then turn on Z rotation variation. So if I turn that up, I can change the variation in all those rotations. Maybe I want to rotate them a little bit around the X-axis, and then I'll add some variation in that so they're not all pointing the exact same way. Maybe I want to have some of them deeper in that plane than others. So let's go to the Z offset here, and let's turn that, let's say, that's actually going to be Z offset here. We have to make sure that we get just the right one. We've got X offset. I think this is actually going to be Y offset. Bring that back. There we go. It's the Z offset there. It's quite a sensitive slider. So there we go. So we get our Z offset. So they're pressed into the Z direction. Now we can change our Z variation, and some of them will be deeper than others, as you can see. Now, if I turn off NanoMesh, I get just my polygons. Turn NanoMesh back on, I can see those individual polys again. Now, if I go to Geometry, Modify Topology, I have the option here, oops, I have the option here to turn on Align Edge or Spin Edge. So I will click Align Edge, and that will align all those polygon edges to be the same. So if we turn off frame mode, Spin Edge, you see it spins those edges so everyone points in pretty much the same direction. Align Edge, if everyone's pointing in the wrong direction, Align Edge will align those to the right direction. So go back to ArrayMesh, and let's say I want to flip them horizontally. I can flip them horizontally or vertically. And you could also add tiling, but that's not going to work particularly well to do tiling on top of the tiling of the skulls. Now, if I don't want to see the planes that these are growing out of, I can turn off show placement and it will hide the planes and just give me that wall of skulls or floor of skulls, depending on the orientation that we want to place it in. Now, again, these are NanoMesh instances. They don't exist as geometry, but we can turn them into geometry if we want to. All we need to do is go to Inventory and click One to Mesh, and that will turn this into actual geometry. There you see those skulls are now visible in polyframe mode. I'll probably want to Control-Shift-Click to isolate the planes from which they're growing from. We'll invert that visibility. And if we want to get rid of that polygon plane, we simply go to, we turn off frame mode, go to Geometry, Modify Topology, Delete Hidden. And that deletes those polygon planes that we were using to grow those nanomeshes. So it's going to be considerably more dense now. It's up to 9 million polygons. So if you do elect to turn your nanomesh into physical geometry, it's always best to make sure that your starting mesh, your instanced mesh, is as low resolution as possible. And you can accomplish that through Decimation Master, or you can accomplish that through using ZModeler to model a simple shape and then instance that to make a more complex shape, which you then turn into actual geometry. So again, we talk more about NanoMesh in the chapter on NanoMesh, but I did want to illustrate how you can utilize ArrayMesh in conjunction with NanoMesh to create complex surfaces and complex organization of objects very, very quickly. So that completes this look at ArrayMesh. I hope you found this useful and it's inspired you to different ways that you can utilize this tool as well. And I'll see you in the next video. Thanks for watching.